Am I audible through other device?
Yes, sir. Audible, sir.
Fine. Have you guys solved the problems that we have given yesterday?
So one problem we are able to solve. Another problem. Second one, it was very difficult, sir.
Second one is difficult. What about
Yes.
others? Prince, yeah, Vishnu. Which one is easy? First one or second one?
First one was easy, sir. Taking moment about E point.
Let me open them. Is it visible? Screen?
Yes, sir.
Yeah, thank you for confirming. You guys are not facing any eco issues, right? At least for now. Okay. First one is easy, right?
Yes,
So,
sir. First one answer is 200.
everybody agrees to it? 200. If you guys want to discuss, then only I'll discuss the first one. Otherwise, I don't discuss the first one. Just now started, Anita. As of now, we haven't discussed anything. Oh, Vishnu, FDF. Forget about FDF. We discuss only about you are talking about the second case. Okay, fine. First one 200. I think everybody agrees, and second one 30. Yes, Prince, can you please explain me where you are facing the problem in first one? We'll briefly discuss about it. Have you tried by yourself, first of all? Don't make it like a regular classes that happens in college. So I think you can unmute and talk. It doesn't matter wherever you are. Except Prince, for others, is it okay? What's
Okay, sir.
one actually? What is the problem with this? So our interest is in finding the force in the member DF, right? So I think what about method of sections and what about method of joints? So here what happens, suppose if I'm talking about DF member, if I go for the method of joints, what I can do first, I should go for this joint and then I should come to this joint. Then again still 3 members are required. Then method of joints, I think it's not easy. Why? Because first if I go this joint, these 2 members will be known. And if I come to this joint, still there are 3 unknown member forces are required. Method of joints can't handle it. Then even if I take this joint, then first I have to solve this and I know the force on this member. And then I'll take this joint, this one and this one I'll know. And then only I should jump to D, isn't it? So the shortest way to solve this by using method of joints is first taking method of three-body diagram at joint B and then at A and then at I and then we have to jump to D. I think B, A, I and then D. I think it is a lengthy process. Why? Because it will take around 10 minutes, I think, if we don't want to commit any mistake. So method of joints is not an option. So obviously we have to go for the method of sections. So if you want to go for the method of sections, what we have discussed such that not more than 3 members, right? So if I'm interested in DF, can I cut like this? This is the first I will choose. Second, I will choose like this. Third, I will choose like this. Let us say this is the third option, this is the second option, and this is the first option. If I want to go it for method of sections, is there any need to select for section 1? If I want to go for method of sections, section 1, is it a better option?
No, sir. There is.
I will be 4, 5.
3 members are, yeah, 3 members are connected to the same joint. So that's why again this will become the method of joints. So section 1 is not an option. If you go for section 2, then you can see it is passing through how many members? Member 1, member 2, member
Members.
3, member 4. Again, this may not be the choice. Even if you go for section 3, it is separating here, 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 and here. Still, as a number of unknowns are more than 4, we cannot find out using the method of sections. But luckily, on this case, what happens if I cut a section like this? How many members are connected if I cut a section like this?
4, sir.
If I cut a section like this, total how
4
many members
member.
are connected?
4
members
member
are
are cutting.
connected, right? But in this case, let me draw the free-body diagram. So let me represent the forces there. Let me represent it randomly. Okay, let us represent this is what F1, and as it member is separating here, this is what I'm representing F2. Similarly, initially I'm assuming all of them are tensile forces. Similarly, this is what the F4. What is our interested in? Our interested is only in F4, isn't it? And of course, external loads are also there, 20 and 10. This is what the 10 kilonewton, and this is what the 20 kilonewton. As you can see, as they have required only F4, then what you can do is that, let us say if you take moment at this joint P, let's say this is the point P. If you see, because of F1 and F2, as they're passing through point B, no movements. Even because of F3, the line of action of F3 is also passing through this joint only. So in this special case, even F1, F1, F2, F3, the line of action of these forces are passing through point P. Only one force that is not passing through is F4. So if I take summation of moment at point P is equal to 0. As you can see, because of 10, let us say the length we have discussed is 3 meter, and even here it is 1.5 meter and 1.5 meter. So if we take moment at this point, because of this F4 clockwise, let us say anti-clockwise movements are positive. So F4 into 3, because of this 20, clockwise again. So plus 20 into 3. Because of this 10 also it is clockwise. Plus again 10 into 3. That should be equal to 0. So if I solve this, I'll get F4 is equal to minus 30. Minus represents, initially we are assuming it as a tensile force, but it is a compression force. So this is what the exemption case that we have discussed here. Even though if I cut the section, 4 members, even though 4 members are there, out of them 3 are passing through common point. That's force in this member can be found by using the summation of moment at point P. So as I told you, these are some exceptional cases that we have to remember. That's it. Nothing else we can do. If 3 members are not passing is an option, at most we have to search for 4 members where any common point where 3 other members are passing through, then you can find out the another unknown. Is it clear now?
Sir.
Prince to chala gaya. Prince has left the meeting, it seems. And Vanita, Ramya, Vishnu, okay, fine. I think no need to explain this case, right?
No need, sir.
Don't want, sir.
I think Bhopati, are you the one who messaged me? Yeah, and as he told me that even he asked you guys, but no one of else. So let me take this problem. There is a load acting here, 10 kilonewton, and this is the hinge joint 1. This is the hinge joint, they have considered as a 3, and this is also the hinge joint, they have considered as a 2. And what they are asked is that a cantilever truss with joints labeled 1, 2, 3 shown in given figure. It carries a vertical load of 10 kilonewton at joint 2. Okay, fine. The force diagram drawn at joint 2 represented as. That means you have to draw the force diagram at joint 2. And the options given are, what do you think these diagrams are? They have clearly mentioned these are force diagrams, but what is the issue? We have to draw the force diagram. Now think about, guys, what do you think these diagrams might be? Just
Is
give
it
me some
SFD?
ideas, get the some ideas. What does force diagram at joint to? What could they be?
Is it shear force diagram, sir?
We are talking about trusses, right?
Yes, sir.
Then axial forces only. How come the shear force will act on them?
Okay, sir.
Only axial forces. Come on, get some ideas. Look at the diagrams, what they have given, and then even though I have not
Sir,
drawn it.
fourth option, sir.
Huh?
Fourth option. The last
What
one.
are those diagrams? What does they represent?
Represents member
What
force.
about member forces, right? That's what they represent them. Like,
Yes, sir,
see,
member force.
yeah, if I draw the free body diagram at joint 2, this is the external applied force, 10 kilonewton. Can you tell me, or by the application of the loads, what do you think? Let us say this is the member 1, this is the member 2. Without solving anything, can you identify that member 1 can be under compression or tension?
Tension.
Member 1 is
Compression.
Compression, sir.
Imagine you are applying a loads like that. Then what is happening? It will compress this and it will elongate this.
Compress.
Right?
Compress,
Member
sir.
1 is under compression. If it is a compression, I will draw a line and I will represent an arrow like this. Number 2 is under tension. So I will draw a line and I will represent a diagram like this. This is what my, let us say, force in member 2. And this is what my force in member 1. So if you want to represent a force diagram, it's just that you have to represent in a cyclic loop. Like, let us say if you are having two forces like this, parallelogram theory, P and Q, what you can do? Parallelogram theory, you can represent a force like this parallelly, and you can draw a force represent like this parallelly, and then this is what your resultant. Just like in the same way, if I rearrange the forces such that, see, 10 Newton, I won't change anything. But as you can see, here two tiles are missing, but one head is missing. So what I can do? Instead, I can draw a diagram like this. And even up to, what I can do is that if I rearrange them somehow, I will represent like this, and then I will represent an F1 force like this. This is what my first 10 kilometer. Now you can see F1 and 10. What is the resultant? The resultant is nothing but F2. That means it's just the rearrangement of these forces at the connected joint such that they will make a cyclic loop. That means, see, F1 is acting like this and 10 is acting like the resultant. Even if you're talking about a bar, if I'm talking about force diagram, means indirectly I'm asking about the axial force diagram. If I'm talking about the beams, if I talk about the force diagram, they can be axial force diagram, they can be shear force diagram, they can be moment diagram. But for trusses, if I'm talking about force diagram, means at the corresponding joint, we are talking about the forces in a members only. So at joint 2, as you can see, two members are connected, one load is acting. So in the force diagram, obviously you can see three parts: first part, second part, and third part, even though the right option is this. So this is also one shortcut to find out the answer. Is it clear? Force diagram? Just you have to represent forces at the connected joint in a cyclic loop. That's it. Can I, as he also given me one more problem, can I give it? Can you guys solve it quickly?
Yes, sir. Please, we will try.
it won't take much time. I think he told me that he have shared it with you. Did you guys tried it? Seriously?
Yes, sir.
But still you guys didn't get an idea why. So see, this problem I'll give you, and I will give you 3 minutes of time. Don't be in a hurry. Calm your minds and then solve it. Even if you take 4 minutes, no issues, but please end up with the correct answer. I'm not giving the options, so try to redraw them. They are asking us to draw the force polygon or force diagram at this joint. And assume that everything is equal, let us say L, L. Even though they have not given, but I'm just giving you. Okay, take 2 minutes of time, try it now. Anybody have completed? At least have you guys find the member forces? 20 kilonewton of what, Anita? 20 kilonewton of BE. BA you're talking about 20. Here we are talking about W. How come 20 came into the picture now? Have you considered them W as 10? What about others, guys? Yeah, they might be. Can I expect from any others? Any others, guys? Only one. Why? At least tell me, are you guys are solving it or not?
We're trying, sir.
Okay, thank you.
Couldn't. I couldn't.
Yes, please. As we have, let's see here, just a second. See, each force represents the either force in a member or the load applied at that joint, right? So
Yes, sir.
let's see this problem. Let's come to this joint. If you come to this joint, can you tell me what about the force in this member AB?
0, sir.
0.
Zero
Because no horizontal.
It is a zero force member, right? Now, at joint by total, how many are connected? How many forces will be there? If you draw free body diagram, BD force will exist, BE force will exist, BC force will exist. In addition, W will also come into the picture, isn't it?
Yes, sir.
That means total, how many lines you can see in the diagram? As 3 forces are existing at joint B, as you can see, 4 lines can be visible, right? Each line represents either force in a member or the applied load. Let us look at this diagram. This is what one force, representation of one force, representation of another force, representation of another force, representation of another force, and then representation of another force. That means in this case, total how many forces are acting at joint B? If I select this diagram,
4, sir, up to.
no, in this, if I
Five.
select this function, total how many?
Force only you can ask.
5.
Is one. This part goes to another force. This part goes to
Sorry,
another.
sir. D will be resolved. BD will be resolved, sir. 5, 6.
So total 5. But if we resolve the forces at joint B, how many will come into picture?
4.
3 member forces, 1 load. So totally 4.
Even though 4 members and 1 load is acting, we know that member force in AB is 0. So only 3 force members will exist, 1 applied force. So total 4 lines should be visible. So this is not a case. If you take this diagram, 1, 2, 3, 4, 5. So this is also not an option. Even if you take this 1, 2, 3, 4, 5. So obviously the first one is correct option, but as the work, please solve it at home. I need you guys to find out these ordinates with values. You know how to find the member forces, either use method of joints or use method of sections. Find out the forces at the connected member of joint B and then rearrange them in a force diagram. Tomorrow, I just want to see this picture from all of you. At least it's clear, right, how to solve it, this case.
Yes, sir. Yes, sir.
Okay, I think we'll move on. If you guys have idea, then I think he has asked me one more problem. Let me quickly wind up it and then. Vishnu, what is your question? Actually, I didn't get you that.
Sir,
How
could you
to-
explain once again, sir? This step only, sir.
Yes, please.
Could you explain once, sir? Once again.
Which one? First case.
Second, sir, sir, you have to eliminate another option, then you can find answer. But how can eliminate, sir? On the
See,
step, once again explain, sir.
if I talk about joint B,
Sorry, sorry, sir.
this is what my member force 1. This is what I can say my member force 2. And this I can say my member force 3. And this is what my applied force W, isn't it?
Yes, sir.
Even though AB is connected, it is a 0 member force. That's why I'm not representing it. So the force diagram means it's nothing but you have to, let us assume that you have to represent it in a closed loop. Obviously, even let us say, if you are talking about two forces, let us say F1 and F2. What can be the resultant of these two? If you find resultant, this can be a resultant. Let us say you are representing in a F1.
Yes, sir.
Even this diagram, you can represent it in a closed loop. So here I can represent this is my F1 and F2. I can take parallel, I will shift to here. Instead
Yes,
that,
yes, sir.
I shift F1 here. This is what my F2. And then what I can do, I can represent my resultant force F4. In this case also I can represent, or I can represent, even I can represent a force like this, F2. I can represent a force like this, F1. F1, F1, F2, and then resultant force. Just we have to represent them in a cyclic loop. That's it. That's what we have done in this case. So here at joint 2, two members are connected, one external force is there. So if I resolve this, as you can see, this is what my representation of the force F1, representation of the force F2, and then representation of the force 10 kilonewton. What I have did is that I have just rearranged these forces such way that they can make some cyclic loop.
Yes, sir.
So this one I haven't changed anything, and this 10 I haven't changed anything, but instead what I did, F2 I have parallelly shifted to like this. So now this is what nothing but your force representation at a particular joint. Just like in the same case, I have at this joint B, even though member force AB is there, as it is a 0 force, I am not represented. Force in member 1, force in member 2, force in member 3, and then W. So these we have to represent in a cyclic loop. So if you represent it in a cyclic loop, as you can see, 4 forces are acting here. So obviously, even if you represent a cyclic loop with these forces, obviously you can see 4 different lines or 4 different arrows. As in the question, they are not represented as arrow. That's why I'm just telling you the lines only. So if I look at the options given, if I look at this option, and this option, I can see everywhere 5 different lines are connected. But as I look at the joint B, if I see in total only 4 forces are acted at joint B. So that's why if I look at the diagram 1, this can be an arrow, and this can be a force, and then this can be a force, and then this can be a force. As you can see, total, each line represents an each force. So 1, 2, 3, 4. So as in this case, directly without solving anything, I can see that 4 connected lines are there in option 1. So that's why I can directly go for option 1 instead of solving.
Perfectly clear, sir. Clear, sir.
Only the logic is that we should understand that member force AB is 0. If you do not understand that member force AB is 0, then what do you think how many forces connected at joint B?
5.
If
5,
member
sir.
force is like this also, total how many member forces? 5. That means, can you choose the option directly? This one, or this one? Can we? We cannot. Why? Because I can eliminate this option, but the answer must be this one, or this one. But unless and until you can't solve the forces at this joint, we cannot find out which one is the correct option. But luckily in this case, as the member force AB is 0, directly we can pick the answer. Clear?
Clear, sir. Clear, sir.
Vishnu, what about this problem? I think this problem is shared by some others. Anita also. What do you guys mean by solve it without any equations?
Sir, me.
So first of all, tell me whether it is determinate or indeterminate.
Sir, indeterminate, sir.
Huh? Sorry,
Indeterminate.
indeterminate to what degree?
1, sir.
1 degree, right? So here 3 support reactions will exist. Here 1 support reaction will total 4 minus equilibrium equations 3. So total 1 indeterminacy. Now Vishnu, can you tell me how can it determinate? Can you tell me how it's determinate? If it is determinate, then we can solve it by using equilibrium equations itself. This is not a determinate case, indeterminate one. Achha, sorry. Okay, fine. Then what do you mean by how to solve without using formula? What is your exact query then? This we cannot solve it by using equilibrium equations, right? Everybody will agree to it, isn't it? How can we solve this? At least with your regular classroom idea, can you give me an idea? How can I solve this problem? At least can you guess it? In explanation book, they solve using formula without considering any load. Which formula they have solved it? Which formula? So as it is indeterminate one,
Sir, in that formula we did slope deflection equations, sir. But how can connect with this concept on slope deflection?
acha, you're talking about 3j minus r. Yeah, we can solve it. You only want to find out by using. You are interested in only in indeterminacy, or you want to solving those unknowns.
In the book, they have asked the kinematic indeterminacy, sir.
Kinematic indeterminacy they have asked you. That means
Yes, sir. Yes.
you guys are interested in kinematic indeterminacy, isn't it?
Yes, sir.
Now see the yeah, we have directly go to slope deflection equation. See here the question itself what they have mentioned. I will tell you in 2 generic cases. Okay, in the question they have mentioned us to find out by using the slope deflection method. So as they have clearly mentioned slope deflection, if you can understand the slope deflection equation, here you can find out if I'm talking about moment at any joint, we need to require rotations at the corresponding member. If I'm talking about member AB, I need rotation at member A, I need rotation at member B. And then delta. Can you know what is delta means in this equation?
Deflection.
Is it a deflection or
Displacement. Displacement.
Which
Displacement.
Displacement, sir.
I need still more clarification on this. Which displacement is it?
Displacements at D and B, sir.
It's not about displacement. We call it as a sinking of support. You guys might have heard it, isn't it?
Yes, sir.
That means if there is a member like this, if this joint has sunk by an amount delta, then because of this sunk, then moments will develop on this beam. So those moments are nothing but a 6EI delta by L square. Those are what they are included in this equation. That means in this case, we haven't considered any axial deformations. Only thing we have to consider is that rotations at the joints we have to consider, and if there is any sinking of support, that we have to consider. So obviously, there is a rotation will develop at B, there will be rotation develop at C, and also there will be rotation will develop at D. So
Yes,
obviously, I should know these three, isn't it? That means if I want to find out the unknowns, theta B, theta C, and theta D, and then only I can able to find out. So tell me, is 3 is the right answer or wrong answer?
So there is a lateral load.
Yeah, there is a lateral load acting on it. So
There may be displacement, sir.
here I just consider two different cases. Kinematic indeterminacy, I don't think I have taught you with any formula. I don't prefer it too. It's a waste of time. You guys commit mistakes, so don't blindly follow it. What is the difference between this problem and this problem? What do you think the difference is?
Sir, first one
Support.
we
Roller
have to
support.
increase support and roller support, sir.
Yeah, so where the difference, even if I'm talking about slope deflection method only, I'm interested in rotations and also I'm interested in delta. That is what my sinking of support. So if I want to use it my slope deflection method, I need to see the unknowns corresponding to these two. One is clear, crystal clear. That
Yes,
is
sir.
theta B, theta C,
Theta
and
B, theta C, theta D.
now we have to look it upon delta. Imagine what happens if this support have moved by an amount like this delta. What do you think? What do you think whether fixed end moments will develop at the corresponding joints?
Right, sir.
In this case, it might not be, but
At the
let us
same
say
time,
B, C, D. For the member CD, delta is which deflection? Axial or bending?
Axial, sir.
Axial. So because of axial deflection for member CD, there won't be any additional movements will develop. What about for member BC and member AB? If obviously this
bending,
is
sir.
moved by an amount, then the reflected shape might be like this. This joint can also move. This joint can also move. So delta is also an important factor in the second. Even though it don't cause any additional movements in the member CD, but it might cause additional movements in AB and BC. So that's why in the second case, delta also we have to consider. But in the first case, as the delta is restrained, so there is no point of talking about delta. Only in this case, if you want to solve it by deflection method, you are interested in theta B, theta C, and theta D, but not the case for the second case. Is it okay? We haven't used any formula here. Shall we move on to the next case then?
Sure, sir. Sure, sir.
Okay, now I think let us complete trusses and then we'll move on to some other cases. I think trusses we have discussed section and then we have discussed important topic, the fourth members. Hope you guys can solve it. And the next important topic is that how to find the deflection. That's one important area where the questions might come, especially in GATE. So before that, can you tell me what is meant by virtual work or what is meant by virtual method? This is the what most frequent method I think you guys might have used to find the deflections in a members. Or can you just explain me what is virtual work?
Sir, unit load method, it can.
A unit load method, virtual load, everything is same. What is the unit load method? Can you guys tell me?
Sir, we have to consider actual load and another case of we have to apply on 1 kilonewton load, sir, and this support.
Yeah. What is the
I
basic?
don't know clearly explain, sir. That is my perspective,
Yeah,
sir.
that's fine. That's great. Yeah, thank you. But what is a virtual work implies? Let us say if I'm talking about a beam, even if I talk about a simple beam, in this case, it isn't stable or not? Stable, right?
Yeah, no, sir.
If you are talking about a stability of a structure, not only stability of if you take any object, if it is in equilibrium, then even if you disturb it by a virtual displacement, virtual why I'm talking about is it does not exist in the real, but even if you imagine or even if you apply an imaginary displacement, then because of that imaginary displacement, the net work done will be is equal to 0. If any object is in equilibrium, if you apply a virtual displacement or apply a virtual force, then net work done won't be affected. That means the change in work done will be is equal to 0. If any object is in equilibrium, this is what the logic. Either you apply virtual displacement or you apply the virtual forces. You don't get any net change in work done. Or you can say change in work done will be is equal to 0. If I talk about the work done, then I can, in general, if I talk about, I can say force into displacement. Let us say if I'm taking an object and if I'm applying a force like this, then if I can, due to some applied force, if it has moved by a distance delta, then work done by the force, I can say it as a F into delta. So here, if as we are talking about the equilibrium of the objects, or if we are talking about the stability of the object, so we have two different types of forces. Applied forces are existing, and also internal forces will also exist. So I can say as net work done is 0, or as I'm saying that there won't be any change in work done. So even if you apply virtual displacement or if you apply virtual force, because of it, work done might be generated internally or work done might be generated due to externally. Externally means because of the applied virtual force. Internal means because of the virtual forces generated in the connected members of the object. So we can say that the work done by the, I can say external will be equal to if I say work done by the internal, then indirectly I am saying that if I subtract these two or if I take anyone to the left or right, then the net value will be is equal to 0. With the same logic, if I take a simple beam, imagine that if I am applying an vertical displacement at this joint, what do you think how it will deflect? As it will not allow anything, then it might deflect like this. Imagine this is what my imaginary displacement that I am applying, let us say imaginary displacement is delta D. And this is what my applied force P. Let us say P is at a distance of L by 2 and L by 2. Can you tell me what about this distance then? If it moved by a distance delta D, what about this distance? Total length is L by 2 and L by 2. If I applied in delta D, what might be this distance?
Del D by 2 also.
Del D by 2, right?
Yes, sir. Half the portion.
As it is exactly at the half. So if I represent the reactions here, the support reaction, let us say this is R. And even though here also reactions will develop, let us say this is the reaction R1 and this is the reaction R2. Now, as you can see, because of this virtual displacement, what is the work done here? I can say this as R into delta D. And because of this applied force P, what is the work done? P into delta D by 2. As these two are in the opposite direction, I can say minus P into delta D by 2 is equal to 0. I can take delta D common here. I can say it as a R minus P by 2. That will be equal to 0. I think we know mathematics, right? See, this is what my virtual displacement. That means very small amount. If I applied in a small amount to satisfy this equation, either this one should be 0, either should be 0. As I'm telling you, as this is very in small quantity, obviously I will make sure that I will make R minus P by 2 will be equal to 0. From this I can say what is my reaction? R will be P by 2. If we solve this by using equilibrium equations, how much we will get? Do we get P by 2 or not?
Yes, sir.
Right? So that means, see, even if you solve it by using, so here we have applied the virtual displacement by an amount delta D. So not only here, you take any problem, or even if you take any complicated problem, and if it is in equilibrium, then if you want to find any unknown reactions, or if you want to find out the relation between any forces, then what you can do, you apply virtual displacement and then make it net work done is equal to 0. Then that will give us the some relation between the forces, or in some cases that will lead us to give the sum unknown. Here in this case, we know that R is equal to P by 2. But in every case, it is not true that again, it will directly give us the unknowns that we need, but it might give some relations too. So this is what if we apply the virtual displacement. Similarly, if I apply the virtual force, let us assume that I have considered the simple beam, same beam, and imagine that there is an applied force P. And imagine that my interest is to find the deflection at point B. So what you can do, again, as this is in equilibrium, let us apply some virtual force. Let us say that virtual force is delta D. Sorry, delta, not virtual force. You know, the reflection might happen like this. And in addition, you are applying some virtual force, delta F. So in this case, what is the work done because of the delta F? Delta B, as we have spoke about, work done by external supports will be equal to work done by the internal supports. This is what the one example for beam case. Similarly, if I want to talk about the truss case, let us if I take the simple truss, and imagine there are some loads acting like this, and because of this applied loads, let us assume that it has deflected to somewhere here. For the deflected shape, if I draw the deflected shape, imagine the deflected shape is somewhere here. On the deflected shape of the object, let us assume that I am applying an imaginary force or virtual force delta F. So what is the work done because of the delta F? I can say that delta F into the deflection happened along the direction delta. Delta F is nothing but a virtual force, and then delta is nothing but a deflection corresponding to the virtual force. This is what the work done because of the virtual force. That will be equal to, because as the members are connected, each member is going to deflection. So here what I can say, because of this virtual force, forces will generate in the members. So those I will consider it as a delta Fi. So here I will consider delta Fy is nothing but a force in the members due to the virtual force multiplied by the deflection of the each member. As here more than one member is connected, so here I can use the summation I equal to 1 to m. To simplify this problem, what is our required quantity? Our required quantity is delta. As our required quantity is delta, delta will go to the other side. As I am telling you, this is what the virtual force. This can be of any amount. For the simplification purpose, what we can do? We can treat it as a 1. So that's why if you want to find out the deflection at any point, if it is a truss member, I can say it as a summation I equal to 1 to m capital Fi. This is what nothing but forces in each member due to the virtual forces are unit force corresponding to the delta I. So if you want to find out the deflection at any point in a truss, just by heart this formula I equal to 1 to m nothing but a number of members, Fi. So here capital Fy represents the force in a member, force in member I due to unit load. This is what the important case. Force in member due to unit load corresponding to the delta. Delta nothing but a deflections in a member. So I think you guys know PL by A. If it is the axial member, what is the deflection in member? PL by A. So here what is Pi? Pi is also nothing but again force in the member I due to applied forces. So wherever you want to find out the deflection, it is simply capital Fi into PIL by AE. Summation I equal to 1 to m. So this is nothing but a unit load. This is due to the applied forces. So here we have talked about the axial force members. Here similarly, we can apply the same logic to even beams or frames or anything. So in this case, wherever you want to find out the deflection, here individual members are connected using the summation. But in the members or beams or frames, we have to use the integrals. Integral, as you might have heard, capital M into small m dx by EI. With the same logic, here capital F due to unit load. Here that we have to speak about small m. That we'll discuss in a couple of minutes, but as of now, clear about this thing. For that, let us explain with simple example. Imagine there is a force acting like this, 10 kilonewton. A, B, C, D. So let us say that my interest is to find out the deflection at B along the horizontal direction. As we know the formula, that will be equal to summation I equal to 1 to, how many members are connected in this case? 5. Capital Fi into Pi L by A. If length and A is also different, then we have to treat them differently. In this case, let us assume that A is equal to constant. And let's say the lengths are 3 meter and then 3 meter. In first case, if you want to find out, you have to find out the capital Pi. What is capital Pi? Capital Pi is nothing but a force in member I due to applied forces. That means because of this applied force 10 kilonewton, what about the forces generated in the members? After that, you have to find out Fi. Fi is nothing but again forces generated in the member I due to unit load. Here, where we have to apply the unit load? we have to apply the
And
unit
the
load
point-
along the direction where we want to find out the deflection. So if I redraw the truss again, just a case, this is a kind.
At joint B, we can apply it on the curve, sir.
As we have to find out the horizontal deflection at B, we have to find out unit, or you have to apply unit force along the horizontal direction. Again, there is one doubt here. In which direction I should apply? Do I have to apply along the right side direction, or do I have to apply along the left side direction? Which one we have to select? Or we can select any one of these.
I think left side.
It doesn't matter, we can consider in any direction. Suppose if I consider like this, and in the answer if I get, let us say plus 0.5.
Tensile.
Again, the same thing.
Yes.
The positive represents that the deflection is along the direction of the unit load. That means if I consider it unit load like this, if I'm getting plus 0.5, that means my deflection at that point is 0.5, and then it is acting along the right side. If I get minus 0.5, minus represents that again the same thing in the opposite direction. That means my deflection at this point is 0.5 mm, but it is opposite to the direction of the unit load. What is the direction of the unit load? Right side. But as I'm getting a negative, there I should say that my deflection at this point is 0.5 mm, and it is acting along the left side direction. So unit load, you have to consider along the direction of the displacement where you have to find. So in generally, even in exam, if you make it all these values in a table, that will be easiest thing. So for making in a table, what we need, member we have to find out. In this case, 5 members are there. So that's why AB, BC, CD, DA, and then inclined member, BC is already connected. AB, BC, CD, which one is missing? AB, BC, CD, DA. DA is not there. CA and BD. CA and BD. And first one, you have to find out member forces due to applied forces, and then find out due to unit load, and then length of the member, and then axial rigidity, and then multiply these values, P, F, L by AE. And then at last, add these all values. That is what nothing but your final value summation. This is what your final answer. So here it looks like very lengthy. If it is an exam, we have to write each step clearly. But in this case, there is no such thing is required. Why? Because you just have to find the values and place it in the corresponding table. It won't be a big issue. So I don't think it will take much time if it is a simple problem. If it is a complicated problem, then it might take time. But the problem that we have given, I don't think it might take a long time. Or instead of A, instead of B, let us say we have to find out at A, horizontal deflection at A. First of all, can you quickly tell me the forces here? Without doing any pen, I think can expect an answer in this case. What is the force in the member AB?
N, sir.
10? Is it
Not
right?
not. Yes, sir.
Everybody agree? Tensile or
Yeah.
compression?
Compression, sir.
Everybody will agree? Compression?
Yes,
Yeah.
As it is a compression, let me represent it as a minus 10. What about member force in AC?
0.
0, sir. No force acting on the member.
Right? I think what about the horizontal reaction here? Can I represent it as a left side 10?
Yeah.
Yes,
Yes,
sir.
sir.
Right? I think quickly I can find the support reactions too. I think if you guys remember the logic, then I can say that this is in the downward direction, this is in the upward direction, and the magnitude is 10. Do you guys agree with this?
Yes, sir.
right?
Sir.
No. What about the force in this member BD then?
No forces, sir.
BD.
Sorry. Upward forces, sir.
Sir.
Compression -10.
Yeah.
And what about the force in this member?
0.
0, sir. No force. No horizontal force because roller, sir.
What about in this member?
That will be 0.
What
Also,
is zero? This member force exists, this member force exists. What about this? See, at this joint, this is 10 and this is, what about this?
0, sir. Because,
Zero.
sir, 0.
If I talk about this joint, left side 10, here it is 10, and here if I assume some magnitude here, let us say F, B, C. And what about this angle? Let us say 45 degrees. How much it will be?
Yes, sir. F,
BC,
BC sin 40 degree. Yes,
45.
sir.
How much it will be?
10 root 2.
These things you guys should be very handy. If you guys are not handy in this problem, then it will be a difficult thing. In this case, at least without pen. See, I'm also giving a random values. At this time, I don't have any notes. I don't have any solved problems, and I'm dictating you all the values and all the problems. I'm taking it randomly, and also I'm solving just like you. Okay, so don't think that I'm having some handy calculation and then I'm saying it quickly. Okay, don't imagine. So what are the zero member forces? AC and CD. So here, as you can see, AC is 0, CD is 0. Then, is there any need to write these values again?
No need, sir, because 0.
No, 0, right? It won't matter anything. Now, what about in member AB? -10, BD is -10, AB is -10, BD is -10, and BC is 10 total. So this is what nothing but applied forces. Now, I'll consider the same truss. Now, what I'm interested in? I'm interested in horizontal deflection at this point. So first of all, I'm imagining that, or I'm applying the unit load like this. Similarly, can you tell me what about the forces because of this unit load?
-1, sir.
That you can see.
AB.
What is the difference between this and this?
We have to operate on unit load, sir.
But here it is 1. Then what? If I want to get the values of this, what I can do? Can I say by 10? If I divide this all the values by 10, how much I will get? If I divide it by 10, how much I will get? 1?
1, sir.
Similarly, that is what the case, right? Similarly 10, similarly 10, similarly 10. So what I can do? Member forces are here if the load is acting is 10. If the
Same
force
as that, but AB and BC and BD. -1 root 2, -1, sir.
and
Similar
what about it is 3. As I know, this is 3 root 2 and this is 3. Let us say AEs are constant. So what about this value? Forget about AE. Minus plus 30. And if you multiply this, how much will get it? 20. 60 root 2. If I multiply here, 10.
Plus 30, sir. 30.
We add all these values, 30, 30, 60. 60 plus 60 root 2. How much?
120 root 2, sir.
Let us say 60 into 1 plus root 2 by 60 into 1 plus root 2 by AE. And what is the direction we are getting here? Positive, right? If it is positive, the deflection is along the azimuth direction. What is azimuth direction? Unit load direction, right side. So,
Compression, sir. Tensile.
deflection is not about compression or tension. Deflection is about the direction. As our deflection value is getting positive, our deflection is acting along the application of the load. Clear?
Clear, sir.
So what is the case? The formula will be simply summation Fi into delta I. Can I say simply like this? What is delta I?
PL by A.
No, deflection in member I due to applied forces. Now, okay, in this case, member CZ is subjected to temperature changes. Okay, member CG is subjected to the temperature change, and let's say the temperature change is there from 30 degrees to 80 degrees. Imagine all these are steel members, and let us say again the lengths are 3 meter, 3 meter, and 3 meter. What I am interested in is, I am interested in finding what is the deflection here. That means if there is a temperature change in member CD from 30 degrees to 80 degrees centigrade, what is the vertical deflection that occur at point G? What do you think this problem will take you? How much time it might take you? Can you tell me?
Just a second, sir.
Just a
Second.
compared to the previous problem, in this case, more number of members are there, right?
No load acting on this any joint, sir.
There are no loads at the point is simply one here. If any of the member is zero, even in the applied cases of this case, then the entire resulting value is different.
Yes, sir.
So how to apply this case to the previous problem? What is the difference? Here delta I, if it is due to applied forces, then you have to find PL by AE if it is because of the applied forces. What if it is due to temperature change?
250 at joint number C.
Del T, sir.
Delta T into L.
Delta
Yes, sir.
T.
Yes.
What is the alpha for steel?
Thermal coefficient.
Thermal
How much it will
Thermal
be?
coefficient, sir. Coefficient of thermal expansion.
11.11 something.
Okay, let us
See,
assume
12
so.
and 12 and 10 power minus 6, sir.
Minus 6, what is the
6.
unit?
Newton per mm square.
Per degree
I'm right, sir. I'm sorry,
degree
sir. 1 by degree Celsius or 1 by Kelvin.
What is this value? Actually, can you tell me? Let us say if there is 1 degree rise in temperature,
Yeah.
what I will get 12 into 10 power minus 6. What is this value means? What is this value? 12 into 10 to the power of minus 6. What is this value?
At the range of expansion, still.
That's why what is the physical quantity that we are measuring this? If I multiply also with delta T, what I will get? Strain rate. If you know the strain, how to find the change in length? Let us say the number length is a strain, you know.
Sir, you said some
Whatever the
kind of noise will develop, sir.
strain that will
Little bit noise, sir.
change of the original length. So whatever the change in length, strain times the length of it. Similarly, if there is a 1 degree change in temperature, strain induced in the member is how much? 12 into 10 to the power of minus 6. So this 12 into 10 to the power of minus 6 is nothing but a strain induced in the member. Is it clear or still the noise is developing?
Yes, sir.
So if there is a 1 degree change in the temperature, what is the strain induced in the member? That is nothing but a 12 into 10 to the power of minus 6. So because of the delta T, what is the total strain? Alpha into delta T. To get the change in length, I will multiply with the length of the member. So this is what nothing but a axial deflection in a member if there is any temperature change. In addition to this temperature change, we might also have some other delta. Delta is nothing but a fitting issues. If members are not fit exactly, if there is an error in fitting, like there might be error of -2 mm or there might be any other errors. So because of those errors also, the deflections might happen. So that's why if it is a truss problem, delta is nothing but if it is due to applied forces, we have to find out by using PL by AE. If it is due to the temperature changes, we have to find out by using alpha into delta T into L. If these are due to fitting issues or fabrication issues, then those values will be issued directly. No need to find out anything separately. Okay. So depending upon the type of problem, we have to use the type of formula. Here in this case, there are no applied forces, isn't it? So that's why no need to write this entire table. Instead, what I can write, in this case, if I want to solve this problem, I will simply say member, and I will simply say capital Fi, and then I will simply say delta I. Similarly, what I will do, I will multiply Fi times the delta I. Now, in this case, I'm having so many members, right? Let us say AB, BC, CD. Forgot about Fy. What about delta I in AB? Here the temperature change is there in which member? Temperature change is there in only member CG. That means the change in length will happen only in CG. So what about the change in length in member AB? Will there be any change in length? Zero. That means as there is only temperature change in CG, except for CG, in every other member, what is the delta I value? Zero. So if this is zero, anything into is zero. That means what is the logic that we can understand? If either Fi is 0 or delta I is 0, what is the net value? 0. So in the exam, you have to see or you have to understand that for how many members zeros are there. If zeros are there, then no need to find anything. Tell me, what is our main objective? Our main objective is to find out the vertical deflection at G. So that means where I have to apply the unit load? I have to apply the unit load like this, isn't it? So if I apply the unit load like this, force might generate in every member, isn't it? Force might generate in this member, force might generate here, force might generate here, force might generate here. But I don't find in any of those members. Why? Because even I take 10 minutes of time, 20 minutes of time, and if I represent it here, if I multiply with 0, what I will get value? 0.
Sir.
So that's why if any one quantity is 0, do not bother about finding the other value. Why? Because there is no point of finding it. So in this case, tell me, delta I is existing only in which member? Temperature change is existing only in member?
CD.
CG. So Fy, I will find out in how many members? As I want to find out vertical deflection, I will apply vertical load here, and then I can find out all the forces in these members. But instead of finding in all of them, I will find out in only one member. That is which one? CG. Why? Because even if I find out for other members, if I multiply with 0, I will get it as 0. So directly what I can say, vertical deflection at Z, that will be equal to force in member CG due to unit load times the delta I. Tell me, what is the force in this member? Because of the unit, there is a unit load here. What is the force in this member? Can you tell me?
1 kilometer.
1
1. So what is the vertical deflection at Z? Because of the unit force, what is the value? 1. Because of the temperature change. What is the temperature change? It is from 30 degrees it is increased to 80 degrees. What is the change in temperature? Change in temperature 80 minus 30, that will be equal to 50. 50 into alpha value is how much? 12
12
into
into
10
10 power 6.
times what is the length of the member?
3.
3. Now final value we are getting positive or negative.
Positive, sir.
That means what is our
The assumed direction is correct.
that means unit load direction is downward.
Downwards.
So the deflection is happening in the downward direction only. Clear? Similarly, is it clear why I have not found the forces in all other members?
Yes, sir. Clear, sir. Because another number. Unit force of
Now see, in this case, there is a fabrication error in the member BC. The fabrication error is minus 3 mm. If there is a fabrication error of minus 3 mm in the member BC, what is the vertical deflection that happened at L? So here the lengths are 3 meter, 3 meter, 3 meter. Don't solve it. At least give me an idea how to solve this problem. Is it a clear question? Just give me an idea how you guys will approach this. Do not solve or don't do anything. There is a fabrication error in the member BC, that is 3 mm minus 3 mm. If so, we have to find out what is the vertical deflection that happened at point L.
Only at the BC member.
Take some time, think about it and can anybody take a lead?
Sir, this minus 3 mm only for BC members.
Yeah. So first of all, tell me, what is this equation I can say? Delta VL that can be equal to fabrication error is there in only member BC. In any other members it is 0, right?
Yes, sir.
That means what I can write down here, fabrication error member BC, right?
Yes, sir.
Force in the members due to which load? Can I simplify this or not?
But where we are applying the unit load? At B or C, sir?
Where we have to apply, where we have to find a deflection.
At L, sir.
L.
Okay. As I want to find the vertical deflection at L, I will apply a unit force like 1. So if there is a unit force applying at 1, tell me what is the force generated in the member BC. How we will find out. At least is it clear this equation? How we have written?
Clear, sir.
Is my screen visible?
Yes, sir.
Okay. Is it okay for everybody this equation? Only there is a, even if I want to write it down, if I want to explain clearly, let us say AB, BC, CD, here, DH. Here I can write down capital F, here I can write down small delta F. So here delta L, every value is 0 except for BC, minus 0, 0, 0. Even though whatever may be these values, if I multiply this value, how much I will get it? 0, 0, 0. If I add finally, I will just because of minus 3 into FBC. So that is what we'll get it, minus 3 into FBC. So that's why instead of writing this entire table, what I'm writing, as there is fabrication error is only in BC, I can simply find out force in member BC because of the unit load. That is what my final answer. Anita, what is the last step that you mean to? Can you please tell me? Anita, am I audible?
Yes, sir.
So much echo is coming from your side. I don't know why. If you write on del BL, see, what is my question? Question is clear, right? What is my question? What is my question? I have to find out the vertical deflection at point L. So if I want to find the vertical deflection at L, where we have to apply the unit load? We have to apply the unit load at L. As I want to find out the vertical deflection, I will apply it along vertical direction. So in this case, there are so many members are there. D, F, G, H, I, J, J, K, L. What about the fabrication array in all those numbers? Except in BC, what about the delta A value in all those numbers? 0.
Sir.
Right?
Yes, sir.
So, even whatever may be this value, what about the force, the member AB due to unit load, if I multiply with 0, how much I will get?
0 will get, sir.
For other numbers, how much will it?
Another also always 0, sir.
Why? Because
0.
delta size are 0.
Yeah.
If all the value exists, that will exist in member only in BC. Right?
Yes, sir.
What is the total value? Total value is nothing but a minus 3 into FBC. What
Yeah.
is this? What nothing but I am saying this is a fabrication error. So,
Yes, sir.
what is the vertical deflection at L? That is what nothing but unit force in the member BC due to unit load times fabrication error in BC. Except these two, all other values are 0. Is it clear now?
Clear, sir. Yes, sir.
Now this value is given directly. How much? This value is given as minus 3. Now what we have to find out? We have to find out what is the force in BC due to unit load. Where we are applying the unit load, we have to find the vertical deflection at L. So in this first, I will apply the vertical load at L. Because of this vertical load, tell me what is the force generated in the member BC. That you guys have to tell me now within 2 minutes. How you guys will find out? Tell me.
At BC, sir.
At BC, there is a unit load acting at L. Now tell me how you will find the force in member BC. Would you like to go by using method of joints?
Not possible because 3 members are connecting. Joint B. Joint B. I'm sorry.
Instead, you guys have to go for
Yeah. Section.
Now tell me, is there any need to find the support reaction?
See, no need, sir. Yeah, on the right side.
So, can I consider a section like this?
Yes, sir.
And which part I should consider, left side part or right side part?
Right side part, because no need to find out reaction.
Just a second. Can you tell me any other section that can be possible in this case? Any other section is possible other than this?
I don't understand.
BC and
Please
GH.
consider.
This is also a possible case, isn't it?
Yeah.
Either you consider the section 1 and you consider the section 2. In both the cases, 3 members are separated. So either you take section 1 free body diagram or you take section 2 free body diagram, your answer will be the same. So take the free body diagram of either 1 or 2 and find the forcing member BC. Which equation you will use?
Summation NH equal to 0.
Summation M is equal to 0. At which point you guys will use?
At H, sir.
H point equal to 0.
Even if you consider section 2, even you consider section 1, you have to take moment at point H is equal to 0. And tell me quickly how much you might get it. This you guys should know it by practice.
4, sir.
How much?
4.
4, 1, 2, 3, 4. What about others? Do you guys agree with her answer?
Compressed.
3, sir, minus 3.
3 or 4?
Minus 3.
3 only, no, sir.
3, sir. 3. I'm sure 3, sir.
Are you guys sure?
Yeah. Sir, yes, sir, 3.
Who got it as 4?
Four.
Can I erase it itself and solve it?
Sir,
which
you
one?
can use separate slides.
Section 1 or section 2 you guys
Yes,
have
sir.
considered? Which one you guys have
Sir,
considered?
section 1, sir.
Section 1.
I have. Sir, I have to consider section 1, sir.
Okay, fine then. Let me remove this too. This is what my forcing number BC, and this is what my forcing number CH. This is what my forcing number. If I take moment at this point, 1 into clockwise direction, 1, 2, 3, 4. 4 3s are 12. Clockwise, that is a positive. Because of this FBC, anti-clockwise, minus FBC into 3. That will be equal to 0. That implies FBC, how much I'm getting? 12 by 3, 4.
4.
How come you guys are getting it as 3?
Okay, sir.
Is it wrong anything what I did?
Sir, right, sir.
Why you guys have got 3? I don't know. Is it okay now?
I made a mistake, sir. Yes, sir. It's clear, sir.
These mistakes are very crucial, okay?
Hmm.
You guys know the concept, but calculation mistake, not at all acceptable. Now, what is this value?
4.
Minus 4 into. I'm
Minus 4 or
sorry.
plus
4 in. I'm sorry, sir. 4 into minus 3 is
4 into minus 3, how much it is?
minus
Minus
12.
12. What does this minus represents?
The direction is opposite.
Direction is opposite direction, sir.
Is a downward, but the deflection is in.
Forward.
Even you can understand, right? If one member is compressed, little bit compressed, then obviously this entire thing will move up. That's how it happened. Can you similarly tell me what is the vertical deflection at F? Without doing any calculation, if I ask you what is the
Sir,
vertical deflection?
minus 1, sir. In upward direction. And
Vertical deflection at F.
Is it 0?
Please
12, sir. 12.
think twice and tell me what is the vertical deflection at F. Same thing, right? What?
12, sir. 12.
Same, right? Where you will get change? This one?
Yes,
The
sir.
same problem. Fabrication is only in this. Again, you have to find out the same thing. But what is the difference? Previously, you have to find out at F, but here you have to find it out at F. Apply a unit load F and you have to find out this value. If I apply a unit load here instead of previous case, what do you think the value of forcing member BC because of this unit load? Will it be same or will it be different?
Same, sir. Same.
So that's why the answer remains the same. What if I ask you to find the vertical deflection at K? What do you think the answer is? If I
9.
ask you vertical deflection,
9, sir. 9.
how much generated? 4 into 3. Now if I apply unit load here, how much will generate?
3 into 3.
3 into 3. That is 9 by 3. So here how much it will be? 9. If I apply load like this, you want to find deflection at A. What is the vertical deflection you will get?
3 mm, sir.
How much?
3 mm.
Here it is 12, here it is 9, here it is
3 mm.
6, sir. 6.
whatever it is, vertical deflection at 3. What about horizontal deflection at F? Can you tell me? What is a horizontal deflection? Let us say if we apply here,
0.
don't guess it, solve it. This one will be same. You have to find out the force in this number. So try to tell me what is the answer. If I apply a unit load here, what is the answer? Question is clear or not?
Once again, show it questions, sir.
Sir.
Only the thing is, whenever you want to find out the deflection, apply the
And-
unit and then find the force and generated in the number.
Sir,
Now
if
you have to find out horizontal deflection at F. So I have applied the unit load there. Now what is the force in this number? A load applied like this.
one, sir. 1
FBC will be equal to positive 1 or negative 1.
Left side, sir. Left side.
positive, sir. Positive.
Positive 1. So what about the net value here? FBC is 1. That will be equal to 1 into minus 3. That will be equal to minus 3. What is that minus? Opposite direction. Got the idea now? Vishnu, how come it is 12? Vishnu, how come it is 12? What about others? Ramya, Anita, Anda.
Sir, I said
Okay, good. Thank you. Ramya,
Yes, sir.
Anita,
Yes, sir.
why you have taken so much time? Vishnu, please. Please, I will be very happy if you do something like this. Vishnu, bye. So let's do one thing. Please go through this topic and solve some questions and get back to me on the next class. And if you guys have any doubts, contact me through WhatsApp. We'll discuss on the next class. So,
okay, sir.
what are the problems we have discussed on the deflections? For the testers, go through them and solve some previous year gate questions. If you guys have any queries, forward me by tomorrow evening, and then we'll discuss on. Okay, fine. Okay, let's stop here. And make sure that you solve some problems and come back to next class. Okay. Thank you.
Thank you, sir.
Please practice.